Everybody, today we're going to be looking at chapter 4, and we're going to be starting with 4.1, obviously, and we're going to be doing a quick review on what exponents are, how to manipulate them. So the first problems we're going to be looking at are just a quick reminder of what you did back in Math 2. As we progress through the unit, obviously we'll be adding more things like how to solve them. So for this first one, remember we really have k to the 1 here. So k to the 1 times k to the 4. As long as our bases are the same, then product rule says that we can add those exponents together, and we get k to the 5th. Okay, for the next one, what we want to do, because there's more stuff going on here, but it's really the same process. I want to look at the 4 and the 6 first. 4 times 6 is just 24. I want to look at my u's. I've got u to the 5th, u to the 5th, so that's going to be u to the 10th. And then I've got v to the 1, v to the 2, so that's going to be v to the 3rd. Okay, so all I really did there was add the exponents. Now remember, multiplication is commutative, so I can move that around. It doesn't necessarily have to be right next to each other to be able to be multiplied, as long as everything is being multiplied. Okay, power rule says that when I have multiplication happening, and it has to be multiplication happening, I can just bring that exponent inside. Okay, now if addition or subtraction is happening, we cannot do that. We have to do what we did in last unit, and we have to actually multiply that out. So be careful with that. But since it's just multiplication, I can say 5 squared a cubed squared b 10 squared, and then really just c squared. Okay, now when you have a power to a power, we just multiply. Okay, and that's the power rule. So this is going to be 25. I'm going to have a to the 6th, b to the 20th, and then c squared. Okay, the next one just combines the two. So I'm going to have 3xy. 3 to the 4th is going to be 81. X 4, okay, power rule here, 2 times 4 is going to be 8z times 3 x y z. Okay, this should be 729 when I multiply 3 times 81 times 3. X to the 3rd, x to the 4th, x to the 1. So 3 plus 4 plus 1 is going to be 8. Y's, 1, 8, and 1 is going to be 10. And then for z's, I just have, this should be a 4th. I have 5 of them. Okay. For this next one, I'm going to skip this one for now because it's basically just an extended version of 6. So looking at 6, I need to be careful here because I have really a negative 1 here. Okay, so I have 2 x y to the 5th, but then I have this 4 that needs to go to both parts. So negative 1 to the 4th, y to the 4th. Now, negative 1 times negative 1 is positive. Negative times a negative is positive. Times another negative, because I've got 4 of them I can get through. So negative, negative, positive. Negative, negative, negative is negative. Negative, 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 negative is positive again. Okay, so even numbers turn into positives, which really means it just kind of goes away. Odd numbers is going to turn it negative. So looking back at this one, I've got a negative, I've got a odd, which is also going to be negative, and then I've got an even, which is going to be positive. Negative, negative gives me a positive, times another positive is going to be positive. So that's just something to keep in mind on these. So for this one, finishing it out, 2x, y to the 9th. Okay, so we're going to be looking at rational exponents. Rationals, remember, are numbers where a is over b, where a and b are integers. Okay, and b does not equal 0 because it can't divide by 0. A can be 0, that's fine, but b cannot be 0. Okay, so what this slide is showing us here is that if we take the square root of something, it's the same thing as taking the 1/2 power of something. So let's just do that real quick. We're going to head over to Desmos here. And really, we just need the scientific calculator, so let's do that. And what this is going to show us is that the square root of 9, which is 3, is the same thing as 9. Now, I need to be careful here that it's actually keeping it up there, but it's the same thing as 9 to the 1/2. Okay, and that works for all of these. What you're going to find is if you did that with any of these, that works for us. So what's happening is the denominator of our rational part is becoming the base of our radical. Okay, which radical base we're taking this to. Okay, and then the one we'll look at later is what's happening with it. But really what it's happening is it's going on the outside. And anything to the first power is just that thing. Okay, so the idea here is if we have a third or a fourth or a fifth, then that's the root of our radical. Okay, and again, this is just double checking that that works for us. Now, at the same time, though, we have that outside part piece now. Okay, and remember, if there's nothing there, then there's that invisible 2. Okay, so if I did this one in Desmos, square root of 5 to the third power. Let's make sure we're using our parentheses. So square root of 5 to the third power. I get 11.1, and let's go ahead and put that up here so we don't lose it. Okay, and the idea is, again, there's that invisible 2, so that's going to be in our denominator on our rational. So I'm going to say 5, raised to the 3 divided by 2, and I get the same thing. So that 3 on the outside stays in the numerator. The 2, that invisible 2 on the 5 or on the radical, becomes our denominator. And that's what happens here. So this is the same thing as 5, 3 over 2. This is going to be the same thing as 4, 2 over 4, which, interestingly enough, is the same thing as 4 to the 1/2, 9 to the 2/3, and then 10 to the 4/5. Again, invisible 2, so 15 to the 3/2, and then 27 to the 4/3. Okay, working backwards. So the top number, the numerator, is going to stay outside. The denominator is going to become our radical. So cube root, because of the 3, of 8 quantity squared, square root, denominator, of 6 quantity to the 5th, fourth root of 12 quantity to the 3rd, and so on. Okay, for these, if you have a different power root, what you want to do in Desmos is this. You want to hit this button here. So for example, we had 12 to the 4th root raised to the 3rd power. I'm going to hit this. I'm going to put that 12 up there. 4. And then I want to raise, I did that backwards. I'm sorry. 4, 12, that's better. And then raise to the 3rd power. Okay. So that's how you do that in Desmos. On a calculator, you're doing the same thing. You're going into math, and then you're doing that. But you can also put it just in this way. And honestly, this is probably easier to put in than this. There are cases where each are equally valuable, and we'll look at those as we continue throughout the unit. Okay, so real roots of n. So remember when we took like the square root of 4? And remember I said if we force that square root, okay, assuming it's not given to us, if we're forcing that square root, then we get a positive and a negative answer. Okay, well, that's going to be true for any even root. If I had the fourth root of 16, that was 2, then we're also going to get a positive and negative answer. If I had the sixth root of 264, I'm going to get positive and negative 2 again. Okay, but if I have the cube root of 8, if I have an odd root, I only have a positive answer. Or negative 8 is going to give me a negative answer, but you're only going to get a positive or a negative answer, not both. So if you have an even root, both answers. Odd root, one or the other, depending on what the inside was. Okay, so let's look at those. So I've got the indicated root is here is 3. So I've got a cube root of negative 216. Okay, so headed over to Desmos. So cube root of negative 216, I get negative 6. Okay, only one answer because of the odd root here. Now I have a fourth root, though. It's an even root. So we're going to do the same thing. Fourth root of 81. Now, Desmos only gives you that principal root, that positive root. But I know, since it's even, I need to have 2. So it's not just going to be 3. It's going to be positive or negative 3. Okay, so Desmos isn't going to give you both. You need to be careful that if it is even, that you want to put positive, negative. Okay, this is just more practice. This is already going to be a fairly long lesson, so I don't want to spend too much time on this one. So I'm going to go ahead and go to the next one. So here, rational exponents, again, the idea of a negative exponent. So the negative exponent rule, remember, says if I have something like x to the negative 2, then that is the same thing as 1 over x squared. If I have a negative, I want to move it into the denominator and change it to positive. That's all that this is doing. I do need to be careful, though, that a is not 0 at this point. Okay, for this one, a being 0 is fine. Square root of 0 is still 0. Fifth root of 0 is still 0. But because it's 0, I can't divide by 0. So a can't be 0 if it's in the denominator. Okay, so looking at this one, again, I wouldn't take this and I would just put this straight in the calculator, but let's go ahead and do it by hand without a calculator and make sure we can do that. So 16, we're going to do, 16. We're going to do the square root and then cube it. Okay, so doing the square root and then cubing it, square root of 16 is 4. Cubing that, again, positive or negative because of the squared. Cubing that, it's still going to stay positive or negative because if I cube something, it keeps that positive or negativeness to it. I'm going to get 64, positive or negative. Sorry, video just went out. We're just going to have to work without it. I'm too far in at this point. Okay, so 32. And we're going to have a fifth root. And then it's to the negative 3, or I can just say 3 under 1. Okay, now honestly on this one, I would take this. I would go over to Desmos and probably have just done it right here. But let's work it out. So the fifth root of 32 is going to be 2. So 1 over 2 cubed. Okay, and I don't need to do positive and negative here because I have an odd root. And then that's going to be 1 over 8. Okay, these ones just throw in your calculators. And honestly, throw them in exactly as you have them. You have Desmos, you have that tool. Please do use it. I'm going to skip over these for now, but make sure you're just rounding to 2 decimal places. For these ones, without using a calculator. So exactly what we just did. So 4 square root to the 5th. Square root of 4 is 2, positive or negative, because of the squared. to the fifth. The fifth odd power is going to preserve that positive and negative. So it's going to be 2, 4, 8, 16, 32. So positive or negative 32. Okay, and that's always going to be true. And then pro tip, anything 1 to any power is 1, always. It never changes. Okay, last thing we need to look at is the real solutions of solving some of these, okay? Not as bad as it sounds, but what we want to do is we want to just kind of do it the way we would do any problem from, back in the 5th, 6th grade. Divide by 4, divide by 4. X to the 5th is going to equal 32. Okay, well, to cancel out this 5th power, we're going to look more at this later. But to cancel out this 5th power, I basically want to take that and multiply it by 1 over 5. Now, if I do it to this side, I need to do it to the other side. Okay, and really what's happening here is this. I'm raising both sides to the 1/5 power. Okay, but once I do that, I get x to the 5 times 1/5, 32 to the 1/5. Well, 5 times 1 to the 1 over 5 is just 1, which is what we want. And then this is going to be 2. Okay, I have an odd, so I only have one answer. So x is equal to 2. Okay, you would do the same thing for this other one. Go ahead and pause it if you need to finish this one. For this other one, we would do the same thing. X minus 3 to the 4th. And we're going to raise that to the 1/4 to get rid of that 4th power. But if I do it to this side, I need to do it to the other side. So if x minus 3, this is going to turn into just 1. So really just x minus 3. Okay, now for this is going to give us a nasty gross decimal answer. So don't do it in Desmos yet. Just hold on. Let's do it all in one step. It's going to be nicer for us. Add 3 to both sides. X equals 21 to the 1/4 plus 3. Going over to Desmos. And I do have a plus minus here. So I need to be careful because of this 4th power. So 21 raised to the 1/4 is going to give me that decimal minus 3. Oops. Minus 3. Make sure we're in the right spot. So there's my first answer. So negative 0.85. Let's just do 2 decimal places, 86. Okay. Now for the negative one, what we're going to want to do is we're going to want to just put a negative out front. Negative 5.14. And then we're good on this. And I believe this was just more practice doing that. And then also more practice. Okay, so again, as you're working through these, if you're getting stuck, please let me know. I don't want to do too many of these because I want to keep the video short for you guys. Please make sure that you are checking in if you're needing extra help. And please make sure that you are coming for office hours if you're needing help, if you're one of my virtual students. A lot of you did not come last quarter, and that really affected you. Please don't wait till the last week. Again, I'm not going to be reopening as many things for as many people this quarter. So please be aware of that. Please be making sure that you're keeping up on track with the pacing guide. Let me know if you have any questions, and I will see you in the next video.